god, it's so hot outside. I need something to drink. Mom, can you make me something to drink?
You're going to college, honey. I think you can make yourself a drink.
Fine. I've never made a glass of Kool-Aid before. I'm not really sure what to do. Should be pretty easy, right? What the heck? There's a weird equation-looking thingy on the back. How do you solve this? If only I knew what to do.
Are you having trouble solving a differential equation?
Who are you and what are you doing here?
Miss Cardackley sent me to help you solve your math problems.
Oh, yes, well, I think I vaguely remember this from class, but I'm not very sure what to do.
Let me look at this. Well, in this case, it would be easiest to use Euler's method to find out what the solute concentration should be after 1.5 minutes. The packet tells us the drink will taste best after 1.5 minutes, when the concentration is increasing according to this differential equation. We need to know how much mix we need to mix into the water. Let's go to the whiteboard and I can show you how it's done.
Yeah!
Euler's method is one of the most straightforward numerical methods for approximating a particular solution. Since the Kool-Aid packet gave us a differential equation, dy dt is equal to 37.5 minus 3.5 t, and the initial condition y of 0 is equal to 50 gallons per liter, we'll have a glass of Kool-Aid ready in no time. The initial condition provides a point at which the particular solution of the differential equation exists. First, we're going to construct a table with t in the first column, then y, then dx dt, and then change in y is equal to change in t times dy dt. So we will start with the point 0, 50, filling in the first row of the table. So now, Ashka, what is the derivative at that point?
So are we just supposed to plug the point into the given differential equation?
Yeah, that's absolutely correct. We know that the derivative at any point, that's for any solution to this differential equation, the derivative is going to be equal to 37.5 minus 3.5t. So once we plug in the point 0, 50, we find that dy dt will be 37.5. Now we know that the slope will probably be changing at each point, but since this is an approximation, let's just assume that the slope is fixed until our next t, and then use the assumption to estimate what our next y will be. In other words, change in y will be equal to change in x times dy dt.
So the change in y equals 0.5. Wait, what do you mean by next t?
Well, the Kool-Aid packet tells us that we have a step size of 0.5 minutes. So our next t would be our previous t, which was 0, plus 0.5. As I said before, we're going to assume that the slope stays constant from t equals 0 to t equals 0.5. So our change in y would be delta t times dy dt. So what would that be?
So 0.5 times 37.5, which was 18.75?
Yep, so when t is equal to 0.5, y is 50 plus 18.75, or 68.75. And the derivative at this point would be 35.75 when we plug in t and y.
Okay, that makes sense, but when will we stop doing this process?
The Kool-Aid packet tells us to find the Kool-Aid concentration after 1.5 minutes, so we will continue until t is 1.5. Can you finish the rest of the table?
I think so. So the delta y would be 17.875, and then the next row, t would be 1, and y would be 86.625. And then dy dt would be 34. The change in y is 17. Now t would be 1.5 and y would be 103.625. Is that it?
Yep, great. So at 1.5 minutes, the concentration of Kool-Aid mix should be approximately 103.625 grams per liter. Now we can make Kool-Aid.
Yay!
In terms of historical context,
Leonhard Euler, an Austrian mathematician, was born in 1707 in Switzerland. He created Euler's method, as well as slope fields, which we will talk about in just a sec. He earned his master's degree at age 16 at the University of Basel and contributed a lot to modern-day calculus. He even broadened his studies to include astronomy, medicine, languages, and physics. Early in his career, Euler lost sight in one of his eyes and unfortunately went blind at age 50. Yet he could still carry out his incredible calculations and mathematical assertions even without sight. Now that we have learned more about Euler, we will go back to the equation we were working on, dy dt equals 37.5 minus 3.5t, and we will put to use one of the things that Euler came up with, which is slope fields.
to see this equation graphically, we can draw something called the slope field. I will teach you how to do this just because you are a good math student and love to learn extra math in your free time.
Yay!
Okay, so slope fields are basically a graph with an x and y axis that plots the tangent lines to a differential equation at every point. Therefore, slope fields are a tool to graphically obtain the solutions to a first-order derivative or dy dx equation. Let's simplify the equation to t plus 1.
Oh, so is this related to what we were doing before with Euler's method?
Yep, Euler's method is solving the problem algebraically, while slope field is solving it graphically. Let's try drawing the slope field now. If we start at point 1, 0, t would equal 1, right?
Mm-hmm.
So if you plug in 1 for t, it would be 1 plus 1, which makes dy dt 2. And if you graph 2,
So the point at 1, 0, the slope would be 2.
yep, that's how you do it. And yeah.
So for the point 2, 0, we just plug in 2 for t, so we get 3.
Mhm.
Okay. Let's see if I can do this on my own.
So Ashka, what did you learn today?
I learned that if we have a differential equation and an initial condition, then we can find the specific value of a point taking that function into account using Euler's method. Also, we can also see how the differential function would look on a graph using the graph of its slope at every derivative.
Yeah.
Yeah!
Now we can have a sip of our refreshing drink.
I was content to in the dark. I was scared of pretty girls and started conversations. Oh, all my friends are turning green.
Your magic
in my dreams. Lady, running down to the riptide, taken away to the dark side. I wanna be your left-hand man. Love you when you're singing that song. When I'm scared you're gonna sing the words wrong. Yeah! Woo! Differential equations and slope fields, everyone.
Euler's method.